So hi everybody, today you're going to be watching this video on factoring completely, and you should have the homework worksheet to follow along and answer some questions and then work with me on some of the examples as we go. So here is our goal. Our goal for today is by the end of this video, I will be able to factor a polynomial completely. So hopefully you'll be able to use your skills of factoring that you've learned in class and the knowledge you get from this video to factor completely. And then when you come to class, we're going to practice and do some more examples. But first, what type of factorings have we already learned in class? And if you take a look at number 2 on your homework worksheet, it says to list the types of factoring that you have learned in class. So take a minute or two, think about it, pause the video, go back into your notes if you need to, and try to recall the types that we've learned. And then when you're ready, hit play and we're going to go over them. So the types of factoring that we've done in class: greatest common factor, or GCF, difference of two perfect squares, or dots, trinomials with a leading coefficient of 1, and trinomials with a leading coefficient larger than 1. So what does it mean to factor a polynomial completely? This is number 3 on your homework worksheet. So to factor a polynomial completely means to continue factoring until all the factors are prime. And to be prime means that it can't be factored any further. And typically this means that you're going to factor more than once, and that sometimes you're going to use the same method twice. So GCF and GCF, or you're going to use dots and dots, or trinomial and trinomial. But usually it's going to be two different methods. So GCF and then dots, or GCF and then trinomial, or dots and then GCF, or vice versa. So something like that. So we're going to go through these examples, and please follow along on your worksheet. So example 1, 6y squared minus 6. Remember that we always check for the greatest common factor first. So do these two terms have anything in common? You should notice that they have a 6 in common. So if I take out a 6, when I divide each of these terms by 6, I'm left with y squared minus 1. And if you look at what's left over inside the parentheses, y squared minus 1 is a difference of two perfect squares. So what we're going to do is continue factoring. We haven't done anything with that 6, so we're going to rewrite it because it still needs to be part of our answer. And then if you recall, when we use difference of two perfect squares, we get two parentheses. One gets a positive, one gets a negative. And then what you do is you square root each of the terms. So the square root of y squared is y. So that goes in the front of each parentheses. And the square root of 1 is 1. So that goes in the second spot of each parentheses. So this whole entire thing, 6, y plus 1, y minus 1, is our final answer. And here we use GCF and dots. Okay? So let's move on to example 2. X to the 4th minus 81. First thing you check for is a GCF. Neither of these two have the same thing to be divided by. So because we have two terms, we go to dots, or difference of two perfect squares. Parentheses, one gets a positive, one gets a negative. If I take the square root of each of them, that's going to tell me what to go in each set of parentheses. So the square root of x to the 4th is x squared. And the square root of 81 is 9. And now you might think that you're done. But if you take a look at this second parentheses here, x squared minus 9, that is also dots, or difference of two perfect squares. Okay, The first one, x squared plus 9, is not, because dots means it's the difference of two perfect squares, which means we need to have the subtraction sign. So, since we're not doing anything with that x squared plus 9, we're going to rewrite it on our next line. Then, the x squared minus 9, we're going to factor. So, two parentheses. One gets a positive, one gets a negative. And now we're going to square root x squared and square root 9. The square root of x squared is x, so that goes in the first spot of each parentheses. And the square root of 9 is 3, which goes in the second spot. And at this point, I'm done because none of my factors can be factored any further. The point of factoring completely is so that you have as many factors, but none can continue being factored. So we're done. And this time we use dots and then dots again. So let's move on to number 3. Example 3. X to the fourth minus 3x cubed minus 4x squared. The first thing we check for is greatest common factor, or GCF. Is there something that all three terms can be divided by? You should notice that they all can be divided by x squared. So when I factor out x squared, x to the fourth divided by x squared, remember when you're dividing you subtract exponents. So 4 minus 2 is 2. So we're left with x squared minus 3 x cubed divided by x squared. 3 minus 2 is 1. So it's x to the first, or just x. And in the last term, we have minus 4 because the x squareds cancel each other out because anything divided by itself is 1. So now we've used GCF, and if you take a look at what's left over inside the parentheses, we have a trinomial. And remember, with trinomials, we take that first number and multiply it by the last number. 1 times negative 4 is negative 4. So that's what I want to multiply to. And I want to add to negative 3, which is our middle term that we're going to split. Okay? So we still haven't done anything with that x squared, so we're going to keep bringing it down. And now we are looking for two numbers that multiply to negative 4, but also add to negative 3. So pause the video, try to come up with those two numbers, and then when you're done, hit play, pick back up, and work through the rest of the problem with me. So the two numbers that multiply to negative 4, but also add to negative 3, are going to be negative 4 and positive 1. So we split that middle term into those two pieces. And now we're going to factor. So the x squared gets brought down because we're not doing anything with it. The first two terms have an x in common. When I divide out that x, I'm left with x minus 4. The second two terms have a 1 in common, and it's actually a positive 1. When I factor out that positive 1, we're left with x minus 4. Once again, you're going to bring down that x squared because it's not being used. And then if you take a look at what's inside the brackets, they have an x minus 4 in common. So that's your greatest common factor. And then what's left over is x plus 1. And that is your final answer. So in this problem, we used greatest common factor and then trinomial. So let's move on to example 4. Example 4 says 2a squared plus 14a plus 24. Once again, we always check for the greatest common factor. So is there something that all three terms can be divided by? They can all be divided by 2. And when we factor out 2, we're left with a squared plus 7a plus 12. And now if you look at what's inside the parentheses, we have a trinomial. So there's a 1 in front of the a squared, and 1 times 12 is 12. So we want to find two numbers that multiply to 12, but also add to 7. So take a minute, pause the video, try to come up with those two numbers to split this middle term into, and then pick back up when you're ready to work through the remainder of the problem. So once again, we have this 2 on the outside that we bring down because we're not using. And we're splitting that middle term into two numbers that multiply to 12 and add to 7. Those two numbers are 4 and 3. So we split that 7a into a positive 4a and a positive 3a. Not using that 2 on the outside, it gets brought down once again. Our first two terms can be divided by a. When we factor out an a, we're left with a plus 4. The next two terms have a GCF of 3, a positive 3, and when I factor out that positive 3, I'm left with a plus 4 again. If your two terms inside the parentheses don't match, something went wrong. So always double check that. 2 gets brought down again because we haven't touched it. There's a GCF of a plus 4, and then what's left over? A plus 3. And that entire thing, including the 2 that we brought line by line by line, is our answer. So in this problem, we used GCF and then trinomial. All right, so let's move on to our last example, example 5. This says x to the 4th minus 7x squared plus 6. So always check for greatest common factor. Is there something that all three terms can be divided by? And here the answer should be no. They do not have anything in common. So because we have three terms, we're going to use trinomial. Remember, there's an imaginary 1 in the front. So 1 times 6 is 6. So we want two numbers that multiply to 6, but add to negative 7. Take a minute, pause the video, try to come up with those two numbers, and then pick back up to follow along. So x to the 4th, those two numbers that multiply to 6 and add to negative 7 are going to be negative 6 and negative 1. And remember, this time we're splitting the 7x squared, so our two terms both have to have x squared. So minus 6x squared minus 1x squared, and then we have that plus 6 at the end that we didn't use. First two terms, they have an x squared in common. So when I factor out x squared, we're left with x squared minus 6. Next two terms, they have a 1 in common, and this time it's actually going to be a negative 1. When we factor out the negative 1, we're left with x squared minus 6. Two parentheses match, so we're good to go. They are GCF, x squared minus 6. Then what's left over is x squared minus 1. If you take a look at these two parentheses, one of them can actually be factored further. Which one do you think it is? It's actually going to be our second one, x squared minus 1, and we're going to use dots, or difference of two perfect squares. You can't use difference of two perfect squares on the first parentheses because 6 is not a perfect square. If you try to take the square root of 6, you'll get a decimal. So I just rewrote that because it's going to be part of our answer, but we're not going to do anything with it. Now, the x squared minus 1, difference of two perfect squares, two parentheses. One gets a positive, one gets a negative. The square root of x squared is x. That goes in the first spot of each parentheses. Square root of 1 is 1, so that goes in the second spot. At this point, we cannot factor anymore, so we are finished. That's our final answer. In this problem, we used trinomial first, and then we used dots. Okay, because at first we had 3 terms. When we have 3 terms, we use trinomial. Then our 2 factors were binomials. So check those binomials to make sure that they can't use dots. In this case, one of them could, so we continued factoring. Okay, so that's the end of the video. Hopefully you were able to take some good notes, follow through with these examples, and we're going to get lots more practice in class.